Here we're going to talk about isosceles triangles a little more in depth than what we have in the past. So far you've learned that in an isosceles triangle, two of the sides are congruent. Those two sides are going to be referred to as the legs, as you can see here. The other pieces would be the base. The base would be the side that's not necessarily congruent to the other two. Now the base could be congruent to the legs, but it's not always going to be. The base angles then, just refer to those as the two angles that touch the base. And then the one angle that's not the base angle is going to be referred to as the vertex angle. And those pieces are going to come up in conversations as we go throughout talking about isosceles triangles. Now the first theorem I have here talks about if you know two sides of a triangle are congruent, in other words, you know that it's isosceles, then what else do we know? Well, what I'm going to do is I'm going to look at sketchpad file here. And here I have an isosceles triangle, and the way I know that it's isosceles is because A is the center of my circle, and then this red segment and blue segment will be radii of the circle. Those are always congruent, therefore I know it's an isosceles triangle. What I want us to look at is the measure of the two angles. And it didn't show up. There we go. So right now you look at the measure of angle B and the measure of angle C, notice they're congruent. Well, it doesn't matter how I move this, those two angles are always going to remain congruent. Now notice where they're at. Angle B, right here, is opposite that side. Angle C is opposite this side, which tells me if two of the sides of my triangle are congruent, well then two angles are going to be congruent as well, and the exact two angles will be the angles that are opposite the congruent sides. So I'm a picture person, as you've seen before, so if I know that the green stuff is true, well then I'm going to point down and show that my red angles will be congruent as well. The actual theorem is written down there in the words. Now in this one, it tells you that two angles in your triangle are congruent, which will change this ever so slightly. Let me tweak this. We already looked at that one. So let's try this. Now in this one, we want to we're going to create congruent angles. So right now I have angle B, and what I want to do is I want to create an angle congruent to it. What I need to do on this is I've created a tool that's going to copy that angle for me, and I just have to click the points in order like it says. I need to click on point A, then point B, and then point C. And that's telling me which angle to copy. And now if I click on point A and point B, it creates that angle. So right now I know the angle here in B and the angle here in A will be congruent. Well, what else is that created here? Notice I have a triangle. But what I really want to know is what kind of triangle is it? So if I look at this length and I measure that, so right now I know the distance from point D to point A is 4.9, and if I look at the distance from point D to point B and measure that, notice they're equal. Now if I change angle B, which is obviously going to change angle A as well, notice my two sides are staying congruent. Come back here. What I have going on is the converse of the isosceles triangle theorem. So this one tells us if two of the angles are congruent, well then two of the sides will also be congruent, and specifically the sides opposite the congruent angles. The next thing I have here is an equilateral triangle. Well, if it's equilateral, going back to the theorem that we just talked about, if these two sides are congruent, here and here, well then the angles opposite have to be congruent. And if we go this side and this side are congruent, well then the angles opposite have to be congruent, which is basically telling us that all of those angles are going to have to be congruent. So what I have in this picture, I'm going to get rid of all that, is not only is it equilateral, but it's also equiangular. Now that's going to conclude our lesson on isosceles triangles.